Welcome to our group's presentation of the design of an earthen dam for Thomond Village for Module WT4014 Soil Mechanics. In recent years, the issue of flooding around Thomond Village has been evident and a solution to this problem was needed. The dam will be designed to withstand heavy rainfall and overflow from the nearby River Shannon. We chose the area highlighted here as a suitable location for a dam as it would offer the greatest protection from further flooding. The research process involved the use of various sources of information including lab recordings, notes from lecturers, websites and reports. The lab recordings and lecture notes were the primary source of data providing first-hand accounts of experiments. The websites and reports were secondary sources providing additional context and background information to the primary sources.
Construction methods of an earthen dam, the roll-fill method and the hydraulic fill method. For preparation of the site, any topsoil, shrubs, trees and vegetation must be removed to ensure that the foundation is stable and firm for construction of the dam. For the roll-fill method, thin layers of 15 to 45 centimeters are compacted with rollers of appropriate weight. Materials such as clay, sand and gravel are used in each layer. The core of the dam should consist of clay as it is an impermeable material, otherwise the structural strength would be affected. Materials are sourced and used from burrow pits and spread by bulldozers evenly across the dam. Each layer is compacted until it reaches its maximum dry density. Each layer is to be tested and aimed to get optimum moisture content. Once the dam is constructed to the desired height, the outer layer must be protected with vegetation or erosion-resistant material known as riprap. Advantages of this method is that it is the cheaper method of the two, and with the aid of plant to compact the soil, it can speed up the construction process, and has lower environmental impact as it only uses soil and not materials such as concrete. Though in disadvantages, maintenance is required regularly to prevent the dam from becoming weak and prevent structural damage. Hydraulic fill method. Construction by excavating and transporting the soil by using water. Pipes called flumes are placed along the external edge of the dam. The materials being used are pumped into these flumes. The soil is discharged at suitable intervals, and the soils that are pumped in go through the natural process when in the embankment. Sludge going within the centre settles after a while, leaving the coarse material deposited along the outer edge of the dam, and the fine material settles along the centre or the core of the dam, leaving in the formation of a zone embankment with an impervious core. Advantages of this method is that the construction of the dam can be quicker as there's no need to spread any material. The method also allows for better compaction of the material, which in effect allows the dam to be stronger than most traditional methods. Disadvantages involve it can be more expensive than traditional methods, very difficult to control the properties of the soil, therefore it can affect the quality of the dam. Regular inspections have to be carried out as the soil can settle and shift over time.
We decided to choose clay as the soil type for our earthen dam. This decision was made through the lab experiments we carried out. The proctor test and the partial size distribution curve were just two of the experiments that really made us see clearly why clay was the best option.
Suitability for site. Soil classification. Limerick City and the surrounding areas are built on very deep, poorly drained soils on floodplains. They are formed in recent alluvium. The main soil around the university is brown podzolic, more specifically couga, a material of sandstone origin with shale and limestone. This is the Limerick City soil map. Couga has a limited use range. It has a lack of sufficient moisture, which is due to the light texture and to the coarse, highly permeable nature of the glacial drift underneath. Characteristics of this soil include many variances in drainage, texture and soil morphology. Limerick has been prone to a lot of flooding in recent years, especially this one in Thomond Village in 2015. The alluvium has been deposited from floods like this one. The foundation of the dam will need to be very deep in order to support the dam in the weak soil and protect the buildings from future floods and high tides. Site access is key in site suitability. The access roads are suitable up to the village, but it may be tricky to transport the materials from the road to the bank of the river. The site may also be accessed from the riverside on boats that could carry materials from a more accessible location nearby.
In terms of quality control in earthen dam construction, it involves testing the soil, ensuring the uniform and controlled placement of soil material, analysing the slope stability, controlling seepage and conducting regular safety inspections to ensure the dam meets all design and safety requirements. Moving on to ensuring the most efficient material is chosen. The materials will need to be tested first of all to identify the best quality, and adequate materials will be tested to identify its dry density and level of compaction. The test involved is a proctor test and the relative density of soils test. Piping is a failure mode where water creates channels or pipes through the soil of an earthen dam, compromising its stability. It can occur through a concentrated leak, erosion between layers, lateral seepage or internal erosion. To prevent piping, seepage control measures like filters, drainage systems and cut-off walls must be implemented, and regular inspections and maintenance of the dam are crucial. Overtopping is a failure mode where water flows over the top of an earthen dam, causing erosion and potential compromising its stability. It can occur due to insufficient freeboard, inadequate spillway capacity, or erosion of the downstream face. To prevent overtopping, earthen dams must be designed and constructed with adequate freeboard and spillway capacity. Sliding is a failure mode where the earthen dam moves horizontally due to insufficient resistance to sliding forces. This can occur due to a poor foundation, slope stability, or seismic activity. To prevent sliding, earthen dams must be designed with stable foundations, appropriate slopes, and proper compaction and reinforcement of soils. Regular inspections and monitoring are also important to detect any potential sliding issues.
We drew out a flow net as it is an extremely useful tool to plot both seepage through the dam and under the dam. It consists of flow lines going in a horizontal direction and equipotential lines drawn here in a vertical direction. It is essential that the equipotential lines intersect the flow lines at 90-degree angles. The area between the flow lines is called a flow channel. We place a filter into the bottom right-hand corner of our dam to entice the uppermost flow line away. Without this filter, the flow line may break the face of the dam, leading to piping failure. Calculations for seepage was first calculated through the dam. This is found by multiplying the coefficient of permeability by the change in head by the number of flow channels divided by the number of equipotential drops. Seepage through the dam was found to be 7.2 times 10 to the power of minus 11 meters cubed per second. We also calculated seepage under the dam. This value was found using the same procedure as before, and we got a figure of 1.2 times 10 to the power of minus 5 meters cubed per second. The factor of safety due to piping is equal to the critical hydraulic gradient divided by the largest actual hydraulic gradient obtained from our dam flow net. This value must be greater than 1, and ours was 1.805. We also calculated the bearing capacity of the dam, and it finds factor of safety to be 3.3.